What if everything you know, everything you've ever seen, touched, or imagined, exists inside a place so strange, so powerful, that it bends the very fabric of reality? What if our entire universe, with its billions of galaxies, countless stars, and endless cosmic wonders, is actually contained within a black hole? At first, this idea may sound like a concept from science fiction or a philosophical thought experiment far beyond our grasp. But in truth, it is a serious hypothesis considered by leading physicists and cosmologists. It challenges our most basic assumptions about space, time, and existence itself, offering a vision of reality more awe-inspiring than anything we have ever dreamed. To begin exploring this idea, we must first understand black holes, the mysterious cosmic objects that are both the death throes of massive stars and the most extreme laboratories of physics in the universe. A black hole forms when a star many times larger than our Sun exhausts the nuclear fuel that powers its burning core. Without the outward pressure generated by fusion to counteract gravity, the star collapses under its own immense weight. The mass shrinks smaller and smaller, compressed into an infinitely small and dense point known as a singularity. This singularity is not just dense, it's a place where everything we understand about physics breaks down. The laws that describe gravity, electromagnetism, and even quantum mechanics cease to function normally. Space and time themselves warp to unimaginable extremes. Surrounding the singularity is the event horizon, an invisible boundary marking the point of no return. Once anything crosses this boundary, whether it's a particle of light or a massive star, it can never escape. Not because it's trapped by force, but because the very structure of space-time is warped so severely that all paths lead inward. From the outside, a black hole appears as a dark sphere, swallowing everything that ventures too close. It seems like a cosmic dead end, a bottomless pit where information and matter disappear forever. But what if that's not the whole story? Now, let's shift our gaze back to the very beginning, the origin of our own universe. According to the Big Bang Theory, approximately 13.8 billion years ago, all of space, time, matter, and energy burst forth from an incredibly hot, dense point, a singularity. The universe expanded rapidly, cooling and evolving into the vast cosmos we inhabit today. This initial singularity bears a striking resemblance to the singularity at the heart of a black hole. Both are points of infinite density and curvature where our physical laws break down. Both are cloaked behind horizons that limit what can be observed. Could these similarities hint at a deeper truth? Could the Big Bang itself be the birth of a universe inside a black hole within a larger, parent universe? Some physicists propose just that. They suggest that the singularity inside a black hole is not an end point, but a seed for a new universe. From the perspective of an outside observer, a black hole may be a seemingly destructive force, but from the inside, it could be a cosmic womb, nurturing the birth of a new cosmos. In this view, when matter collapses into a black hole, it doesn't vanish into oblivion. Instead, quantum effects, the strange, probabilistic rules governing the microscopic world, might cause the collapsing matter to bounce back, creating a new region of space-time that expands and evolves independently. This new bubble of space-time could be our universe. Imagine, then, that our universe is the interior of a black hole formed by the collapse of matter in another universe, a parent cosmos whose own laws and constants might differ from ours. Our Big Bang would be the moment of rebirth, the birth of our cosmic bubble inside that black hole. And if this is true, then every black hole in our universe might be the seed of yet another universe, with its own stars, galaxies, and perhaps even life. Universes could be nested within universes, a fractal-like cosmic tree growing infinitely in all directions, forever spawning new realities. This perspective also offers an elegant explanation for one of the most profound mysteries in cosmology: why the laws of physics and the constants of nature in our universe seem so finely tuned to allow complexity and life. If universes are born inside black holes with slightly different parameters, then those universes capable of producing black holes, and thereby new universes, would naturally become more common. It's cosmic natural selection on the grandest scale, where universes with physics favoring star and black hole formation give birth to more offspring universes. Over countless generations, this could explain why our universe appears so exquisitely designed for complexity, without invoking chance or divine intervention. But what does this mean for us here and now? If our universe is inside a black hole, then the cosmic horizon, the edge of our observable universe, may actually be the event horizon of that black hole. Beyond that boundary lies the outside universe, the parent cosmos that birthed us. Yet, by definition, we cannot see or communicate beyond this horizon. It is a barrier not just of distance, but of fundamental physics, a limit to what is knowable. This raises profound philosophical questions. Are we truly isolated islands of existence, forever sealed inside our cosmic bubble? Or is there a way to peer beyond the horizon, to glimpse the parent universe, or the universes beyond that? Today, our scientific understanding is still incomplete. The marriage of general relativity, which governs gravity and large-scale structure, and quantum mechanics, which governs the very small, remains one of the greatest challenges in physics. The singularities at black hole centers and the Big Bang represent the frontier where these two theories collide and falter. Yet, advances in theoretical physics, including string theory, loop quantum gravity, and holographic principles, offer promising paths forward. Experimental efforts, such as the detection of gravitational waves and the study of cosmic microwave background radiation, may one day reveal subtle signatures hinting at our universe's black hole origin. Imagine what it would mean to discover that our universe is not the entirety of existence, but a single branch in a vast cosmic family tree. A universe born inside a black hole, surrounded by countless sibling universes, each unfolding their own stories in the grand multiverse. It would be a paradigm shift on the scale of Copernicus and Galileo, revealing that our cosmic home is both incredibly vast and intimately connected to a grander reality beyond our reach. So the next time you gaze up at the night sky, consider this. You might be looking outward from the heart of a black hole, a glowing island of space and time born in the depths of another universe. Every black hole you see out there might be a gateway to a universe you will never visit, but whose existence depends on the collapse of matter in this one. We are, perhaps, inside a cosmic womb, the child of a star that died long ago in another cosmos. And within us lies the potential to understand, to explore, and to imagine realities beyond our wildest dreams. Because the universe, or multiverse, is far stranger, more beautiful, and more mysterious than we have ever dared to imagine. And that is a truth worth pondering as we look to the stars and wonder what lies beyond.